Welcome back, everyone. So I took a few days off. I had surgery a few days ago, so I've been recovering, but back at it now. So we are on to 5.2, solving linear equations. And this is a really important section. This is like the bread and butter of algebra. So it's not that hard, but it's important that we get really good at this because, again, this is like the core of algebra. So first of all, what is a linear equation? So it comes from the word line. So you see the word line is in here because if you were to graph a linear equation, it would be a straight line. So if we have some graph, a linear equation might look something like this. It would be just a straight line, as opposed to an exponential equation, which might look like something like this. It might start straight and then sort of curve up. That would be an exponential equation. So a linear equation would make a straight line. And it's going to have no exponents on the variable. It could have exponents. It could be like something like 5 squared on the coefficient here. That would be fine, but there's not going to be any exponents on the variables. So in order to solve these, typically when we say to solve a linear equation, we're talking about isolating the variables. Meaning when isolate means get it by itself. So it should be x equals something or y equals something. And in order to do that, we can perform the same mathematical operations as long as we do it on both sides. So if you think of something like 3 minus 1 equals 2. Remember a few sections ago I said, let's start thinking about the equal sign as just saying that both sides have the same value. 3 minus 1 has some value, and 2 has some value, and they match. They're equivalents. They're equal to each other, right? Well, if we mess with this equation a little bit, let's say we are going to add 2 to both sides. So let's say 3 minus 1 plus 2. And first of all, let's say we don't add 2 to the other side yet. Let's the other 2. Is this true? Is this a true statement? So 3 minus 1 is 2, plus 2 is 4. 4 does not equal 2, so that's not a true statement. So we can't do that. But if we also add 2 to this side, right, because we added this plus 2 here, and we added this plus 2 here. So now 3 minus 1 is 2, plus 2 is 4. Okay, so that's 4 on this side, and 2 plus 2 is 4 on this side. So then that works. So as long as we do the same thing on both sides, then we can do that. So one thing to keep in mind though with like multiplication and division, let's say we want to multiply both sides by 2. It's the entire side you have to multiply by 2. So you can't just say 3 minus 1 times 2. Because then that would be, and say like equals 2 times 2. So you cannot do this. This will not work because the order of operations say we do this multiplication first. So 1 times 2 is 2, and 3 minus 2 would be 1. And then be 1 equals 4. That does not work. What we have to do is multiply 2 across the entire side. So if we're going to multiply by 2, we could do that, but multiply the entire side. So now we can either distribute or we can do the parentheses first. So we can say 3 minus 1 is 2 times 2 is 4. And then we have 2 times 2 is 4. And now that does check out. That is good. All right. So anyways, let's go ahead and jump into some problems and practice this. So we have x minus 12 equals 289. So use your understanding of numbers to find a value of x that makes the equation true. So we have some number x here. And in order to get to 289, we need to have some number that when you take away 12, then you get 289. So that must mean that whatever it started at was 12 more than 289. So maybe if we were to just add 12, we would get, let me find the right page on my book. There we go. We had 12, we get 301. And so if we had 301 here, so 301 minus 12, then we would get 289. All right, so use a number line to find a value of x that makes the equation true. So same thing, number line here. All right, so we have 289 somewhere. Let's put 289 right here. We have x somewhere. Let's put x right here. We know to get from x to 289, we have to go down 12. We have to subtract 12 minus 12. All right. And it would be the same thing. So this would end up being 301. We go down 12, we get to 289. Okay. Now, what number can be added to both sides of the equation to give an equation in which x is alone in the left side? So we have this equation, x minus 12 equals 289. And what this is saying is there a number we can add to both sides to get x by itself? Well, right now x is not by itself because we have x minus 12. We want to get rid of this minus 12. And how do we get rid of this minus 12? We can add 12. So we can say plus 12. And if we do it to one side, we have to do it to the other side. Oh. So we'll do plus 12 here. All right, so if we have a negative 12 plus 12, that would be 0, right? So on the left side, we just have x. This cancels out. X equals, now on this side, we have 289 plus 12, and that'll be 301. So this will be the way that we do most of these equations here. Okay, so let's go ahead and solve these. First of all, there's a video here. If you want to go check out another explanation of how to solve these, go ahead and check out that video in the description below. Okay, so same thing as before. In order to get x by itself, we want to get rid of this other stuff. So instead of minus 4 2/3, we're going to add 4 2/3. 4 2/3 to both sides. Plus 4 2/3. We know this side here, these are going to cancel out. So we're going to be left with x equals something. All right, so now we have to add these mixed numbers. So we're going to have, we can add the integers first. So we'll have 6 plus, and then our fractional parts, we have 4/5 plus 2/3. If you remember how to add fractions, we need a common denominator. So let's just multiply top and bottom by 3 and top and bottom by 5 here. And so we'll have 6 plus, so let's see, 4 times 3 is 12 over 15. And here we'll have multiply 5 and 5, so we'll have 10 over 15. All right, it's going to give us 6 plus, looks like 22 over 15. And our numerator's larger than the denominator, so that means we can take an integer out of this fraction. So looks like we can take a 15 out of 15, so that's going to be 7. And what's going to be left looks like 7/15. So x is equal to 7 7/15. And we could check our work by starting back from the beginning and putting 7 7/15 back into this equation right here and see if we do 7 7/15 minus 4 2/3, if we get 2 4/5. And we would, and we'll do that in a future problem. Okay, so now this next one right here. All right, so this one looks a little bit messy right here. And I think in order to solve this one as easy as we can simplify this a little bit more. So 4 minus 5 1/5, that seems fairly simplified. We could simplify it more if we wanted to convert to fractions, but for right now, let's go ahead and leave this side as is. Equals. All right, so we see on this side we have a 2x and we have a minus x. If we were to convert this to addition plus negative x, now we can use the commutative property. We could put the 2x minus x next to each other, and we're going to be left with one x left, right? If we have two x's, and we take away an x, then we'll have x left. Okay, we still have this plus 3 and plus 3 1/5. Okay, that makes it a little bit easier. Now let's go ahead and get x by itself. We'll isolate x. So in order to do that, well, let's get rid of some of the stuff. We can subtract 3 from both sides. And then we'll be left with 1 here, minus 5 1/5, equals, we still have this x, this canceled out, and we're left with this, plus 3 1/5. Okay, we're almost there. Now we can subtract this 3 1/5. Again, do it to both sides, minus 3 1/5. Well, 1/5 and 1/5, that's going to cancel out. That's nice and easy. And this will cancel out, and we'll be left with 1 minus, we have if we convert this to negative, we have negative 5 minus 3. It's going to be minus 8, okay, equals x. So then x is going to be negative 7. So negative 7 equals x, or x equals negative 7, however you want to write that. And again, if we were to plug that into this equation here, we should get a true statement, an equal value on both sides. So x equals negative 7. Didn't really write that very well. There we go. All right, consider the equation 31x equals 713. Okay, so what number can we divide both sides of the equation to give an equation in which x is alone on the left side? All right, so now we're dealing with some multiplication right here. Because remember that 31x means 31 times x. So we can't just do minus 31, right? That wouldn't really work, because then we'd just be left with 31x minus 31. We can't get rid of that 31 because we're not adding 31 to x, we're multiplying 31 by x. So how do we undo multiplication? Well, we can do that with division. And if this is 31 times x, in order to get x by itself, we would have to do divided by 31. Because if you remember back from our fractions, if we did something like this, 31x over 31, well, we could split that up into 31 over 31 times x. And this is just 1, right? So we'd be left with just x. So that's what we're going to do. But if we do it to one side, we have to do it to the other side. So 713 divided by 31. All right, and then we're going to be left with x equals, let's see what 713 divided by 31 is. Looks like we can do 20 of these here. So this would be 620. And we'll be left with 3. And looks like this is going to be 93. And so then we could do 3 more of these, should be 93. 93, yep. All right, so 23. X equals 23. And if we were to plug this back into the equation and say 31, and now x is equal to 23, 31 times 23, that would equal 713. And we know that because we just did the division, that 31 times 23 is going to be 713. All right, let's go ahead and solve these equations. So 5t equals negative 13. Well, we have 5 times t. So in order to get t by itself, we would have to divide both sides by 5. Divide by 5, divide by 5. Okay, and then we're going to be left with t equals negative 13 over 5. That was quick. Okay, so this one right here, we have negative 75 times y. Let's get rid of that. We can do 2 steps at once. We can get rid of the negative and we can get rid of the 75 by just dividing by negative 75. And same here, negative 75. So then we'll have y equals negative 24 over 75. And I don't think that can be simplified. Let me check real quick. Oh, we can simplify it. Okay. Right, because they're both divisible by 3. So 24 divided by 3 would be 8. Remember, this is going to be negative. And 75 divided by 3 would be 25. So 8 over 25 would be simplified. So y equals negative 8 over 25. All right. This next one right here. All right, well, we have, if we want to rewrite this and say u divided by 7, it's the same thing as a fraction, right? Equals, let's say 3 over 14. We can write this side whatever way we like, 3 over 14. All right, so now we have u divided by 7. In order to undo division, we can use multiplication. So we can say u times 7. All right, if you divide something, let's say we have 4. If we divide by 2 and then multiply by 2, what's going to happen? 4 divided by 2 is 2, times 2 is 4. So it just cancels out. We're just left with whatever we started with. It's the same thing over here. But if we multiply by 7 on one side, we have to multiply by 7 on the other side. So we'll be left with u on one side. U equals, well, 7 times 3 is going to be 21. 21 over 14. And it should be obvious, these are both multiples of 7 here. So that'd be 3 over 2. So u equals 3 over 2. And let me check that answer. Yep, that's right. All right, and then this last one right here. Okay, so this one is interesting here. So we have negative 2r over 9. We could do this a couple different ways. First of all, we could do it in 2 steps. We could multiply both sides by 9. That would get rid of this, right? If we do times 9, then these would cancel out, times 9. And then we could divide by negative 2. Or we can do this in 1 step. And in order to get rid of this negative 2/9 r, because remember we can write this as negative 2 over 9 times r. It'd be the same thing. You can just pull that r out, equals 8 over 15. We can cancel this whole thing out. We learned about reciprocals and things like that. So the reciprocal of a fraction is just the flipped over fraction. So we could divide both sides by negative 2/9, right? Because this is multiplying, negative 2/9 times r, so you can get rid of the whole negative 2/9 by dividing by negative 2/9. And division is the same thing as multiplying the reciprocal. So we can say divided by negative 2/9, or we can say times negative 9 over 2. And what happens if we do times negative 9 over 2? Well, negative and negative becomes a positive. 9 times 2 is 18. 9 times 2 is 18. It'd be 18 over 18, so this would cancel out. So times negative 9 over 2 over here also. Got to do it on both sides. And multiplying fractions is easy. First of all, positive times a negative is going to be a negative. 8 times 9 is going to be 72. And 15 times 2 is going to be 30. Now, these are both even numbers, so we know that this can be simplified. Let's see. So 72 cut in half, I believe, is 36. It's going to be negative. So 36 over 15. Let's see. So 15 is a multiple of 3. And 3 and 6 are both multiples of 3, so this has to be divisible by 3. So negative 12 over 5, and 5 is a prime, so it looks like that is the end of the road for us. So negative 12 over 5, that would be our solution for r. So the full solution would actually be r equals negative 12 over 15. And again, go ahead and check out this video over here. Link in the description. Oh, and that was it. So I think it was only 4 exercises, or 4 problems for this section. So nice and quick. But go ahead and practice these. Again, super important. The next section is more of these. It's just more advanced linear equations. But hopefully you got a good handle on the simple versions of these problems. So go ahead and get some practice on this, and I'll see you next time.